That's it. I was not waiting.
So, whenever I'm doing this, obviously we're going to go over these. I'm just trying to get you guys to really bring out whatever math you know. Make mistakes now. Now is a good time to make mistakes, so you don't make them on the test, right? So, and then check out with people around you. Don't freak out if somebody knows more than you. Big deal. This class is weird because you all have very different backgrounds. Some of you guys took your last math course 10 years ago. You're probably not going to be all that good at it. Some of you guys just came out of high school and you did worse on the placement test than you should have. Maybe you should be in 110, so you're going to know your shit really well. So, I mean, just deal with that. There's just going to be a lot of different abilities. All right. So again, do you always have to do all these steps? No. I just wanted to show you a problem that had all those steps. The very first problem, there's not a lot going on, right? So it can't possibly have that many steps. But again, the idea is, where's my x? Which term has my x in it in the first problem? 2x. 2x. So I want to get 2x by itself, because what's the thing I almost always do last is divide. So get the thing that has, in fact, think about it like this. What would you add to 3 to make 9? What do you add to 3 to make 9? Don't look at it. You add 6 to 3 to make. So 2x has to be 6 in order for that equation to be true, right? You guys kind of with me? So this is a problem that you don't even need algebra for. And there are word problems that you don't need algebra for. But what class are you in? So you always have to use algebra, right? Because we're learning algebra. But this one you can just go, well, okay, 2x has to be 6, so therefore x has to be 3. Well, twice what is 6? 3. So you already know the answer should be 3. So if you can do that, really nice, but show me some work, right? You already know what the answer is, now go use algebra to get that answer. But watch, this is what algebra does, though. It says, you know 2x should be 6, so the first step, the first step is, I want to get 2x by itself, so how do I kill plus 3? Minus 3. Got to do it to both sides of the equation, right? So then I get 2x equals 6. Now look how, you're your own worst enemy sometimes. Some of you guys do things all over, the equal sign disappears, and then easy mistakes happen because you move stuff to one side without changing it and all this stuff. If you're just you got to be kind of methodical, right? If you don't like doing that, you got to kind of do that. And then the last step here, yeah, almost always you'll divide last. X is 3, like we knew it had to be. I like it. Twice 3 is 6 plus 3 is 9. Sweet, it works. Okay. And you guys are all like, get to number 5. No, we're good. So again, if you have to, your I should always be drawn to the parentheses, because that means you have to do that first. So somebody was asking me, why can't I just add 5? Does anybody know why I can't just add 5?
We need to open the...
Because it's not really 5. Where is the 2x and the 5? Isn't it it's stuck inside. I want you to really look at it that way. So if you distribute the 2, now you freed them up. They can move around now. You're free to move about. So when you distribute, what do you get?
4x.
4x.
Minus 10.
Minus 10. What happened? Oh, you want to put my hand there? It gives all. Equals 22. How's that?
Yeah, 4x equals 22. 32.
All right, because what do you do next? How do you kill the negative 10? Add 10. You got to make sure that whatever you just did actually canceled. So a lot of people just do this and then just put 4x. They put minus 10 without really saying, wait, that would make minus 20. That makes the problem worse. Wait a minute. So add 10. That goes away. Add 10. 4x equals 32. And then almost always I divide last.
Divide 4. 8.
8. Cool. I like it. And if I check it, twice 8 is 16, minus 5 is 11, times 2 is 22. So it works. Kick ass. All right. I like it. So number 3, of course, is just a few more steps added in. But the very first thing I do is pretty much almost always distribute. Yeah, look for those parentheses. I got to free that stuff up so I can put like terms together. So I get 3 plus
Plus 10.
10.
Minus.
Don't forget the poor little minus 4 equals negative 6. I like it. That's a weird 6. Got a big forehead. And now, I mean, you can do this out of order, but if you're not the most comfortable with equations, do exactly these steps. Distribute. Each side is its own little problem. Get your like terms together. Negative 6, I got nothing to do there. But over here, what can I do? What's 3 plus 10 minus 4? 3 plus 10 is?
13.
Minus 4? 9. And there's my minus 5x is just sitting there. Is that cool?
Yes.
And then, good. All my x's are together already. So I want to move my numbers to be together. So I subtract 9 so they get away from the x's, right? So be careful. I know this is subtraction, but this is positive 9. So isn't 9 minus 5x the same thing as negative 5x plus 9?
Yes.
So that's why you're really kind of doing the opposite sign in that respect. So minus 9, so you get negative 5x equals negative 15. And then like always, you almost always divide last. X is, careful, positive 3, because the negatives cancel. Okay, cool. And again, if you check it, 2 minus 3 is negative 1, times 5 is negative 5, plus 3 is negative 2, minus 4 is negative 6. It works.
Wait, it was positive 3?
Second? Yeah, positive 3 because the negatives cancel. Alright, how we doing? Alright. Just remember, if you're surrounded by people that are doing like this and you're not doing okay, several of these people are lying to me. You understand? This is always true. Yeah, sure, man. I don't want you to know. So let me know if there's a question. Alright, number 4 freaked a few of us out a little bit. It's just a little bit more stuff, right? So what's the first thing I do, though? I look for these things, and I don't care about anything else. The negative 1 just comes for the ride. 5 times 2,
10.
5 times negative 2x
Negative 10x.
equals, the x and the 4 just sit there, and then I get
2x.
minus 2x. Good. Negative negative is plus.
Plus
I love.
14.
I don't think I saw anybody make that mistake, and that's one of the most common mistakes is to put negative 14 down because you forgot it's actually a negative 2 that you're bringing in. And those negatives always find a way to kill us, right? Or hurt us. We survive. So on this side, each side now I can treat like its own problem. What's negative 1 plus 10?
11.
No. 9.
Oh, no, 9. Sorry.
That's right. And then over here, x minus 2x, negative x, 4 plus 14,
Plus 8.
plus 18. All right, let me stop there. All right. You guys good? All right. I always got to remember, some of you guys look like you want to hurt me, but it doesn't mean that. Yes?
Why was it minus 2x instead of minus negative 2x?
There's only one negative. That's why. I mean, that's the quickest answer. So negative 2 times positive x is negative 2x. But negative 2 times negative 7, that is negative 2, negative 7, so that becomes positive 14. All right, so now, you almost always get to this point in these more advanced kind of solving equation problems. Pick a side to put your x on, and pick the other side is going to be where you put your numbers. So it's up to you. What did you guys do? Okay, add x to both sides? Okay. So you get 9 minus...
9 or negative.
What's negative 10x plus x? Good. Equals 18. So a few of you guys got there. If you didn't do that, if you subtracted, if you added 10x instead, you got positive 9x on the other side, right? I like it. So you're okay. We're going to end up in the same place.
What if we move the x to the other side, we make it...
That's what you said. So what did you do? Did you add 10x to the
We
other side?
moved x's here, the numbers here.
Oh, we're doing the same thing. We're moving x's to this side, and we're going to move the numbers to that side now.
Yeah, but we'd like to do it like
One time.
One time.
Oh, that's fine. You guys could do multiple things at once. When I'm teaching, I'm going to show a few more steps. But at least if you show me you're doing all these things, I think I did a couple things somewhere. I can remember. But yeah, you can do a couple things at once. So here, what would I do next?
Subtract 9.
Yeah, so you could have subtracted 9 at the same time. You're fine, but let me see. Subtract 9, and I get negative 9x equals 9. divide by -9, I get x equals -1. And then, of course, you can plug that back in to check it. It will work. So let's get to the freaky one. Oh, good, I got time. Oh, sorry, yes, sir.
Can you hold that up there for a second?
Yeah.
So you have 9x equals 8, or negative 9x equals 18.
No. Nowhere up there does it say that. I've got 9 minus 9x equals 18.
Okay.
And then I subtracted 9 from both sides.
So I didn't get it. Okay.
Is that cool? Okay. I like it. I like it a lot. Okay. So I'm going to get a fresh sheet because there's a lot of stuff in the way there. All right, let's take a look at this one. So this one looks innocent enough, right? Or as innocent as a math problem can look. And again, I just look for these. So I'm just going to do this.
6x 8 minus
15 minus 3x. So everybody should have done that first. We should be used to distributing first. Well, that's a big old long problem.
But you have 12?
No, I don't. That's just a big plus sign. So. Yeah, I like it. I like that though. Please be on me the minute I make a typo or something, a mistake. Let me know. I'm human. I'm not going to be, oh, I don't make mistakes. Screw that. I make mistakes all the damn time. So 6x minus 4x minus another x is x. Is that cool? 6x is minus 5x is 1x plus 8. So I just consolidated all my x's on that side. What can I do on this side? 15, yeah. -3. Everybody had trouble with this. -3 plus 4 is positive x. But I think you guys think the minus sign has to come, but that's -3. Plus 4x is now plus x, so that's what you put. You put a plus x. And 15 plus 2 is, so 17 plus x. So some of you guys didn't have the freakiness happen, and you ended up with the wrong answer. Sorry. The right answer is freaky. So the next thing you would do is minus x, and some of you guys even moved the numbers so you got like 0 equals 9. But no matter what you do, I really want to make this make sense.
We need to take.
Watch. You ready? Let me say this. When you get an answer, what this answer means is when this is true, then this is true, right? When x is 3, then 2x plus 3 is 9. Is that cool?
Yes.
And that's not the way you would normally say it. You'd say the answer is 3, right? But that is actually technically what's going on. So that's always the way you can look at an equation. When this is true, then this is true. When is 8 equal 17?
Never.
So when is this true? Never. So what's the answer?
An untrue statement.
No, that's not the answer. It's an untrue statement, therefore there is no solution. Don't put undefined. Don't put not equal to. I know 8 doesn't equal 17. You're not telling me anything. The answer then is no solution. No. Is everybody cool with the fact that math gives us, there are situations where there are no solutions? I got time. Hold up. Real quick. If I had a lemonade stand, and I set up the equation for my profit for the next month, and I said, let me calculate, I want to make $5 billion. I think the equation I set up is going to have no solution. There's no way for me to do that. There are situations where there's going to be no solution because there's no way to make that happen. What you want to have happen can't happen. So that's why we get no solution sometimes. Is math saying, dude, you can't do that. So that's fine. It's fine for that to happen.
What is an untrue statement? Isn't that an untrue statement?
It is, but what does the fact that it's an untrue statement means what? You got to tell me what the answer is, that there's no solution. That's the answer. There is no answer. So if you just say untrue statement, it's not enough. You got to tell me what the answer is.
Problem. The answer would be no solution.
Because it's untrue. I like it. Yes.
So, for example, you subtracted the x's first, though. What if you can
Oh,
subtract
totally.
one? So it was 0, but it's still untrue.
Exactly. So if you got 0 equals 9, it's still an untrue statement.
Okay, so then...
Because then I can add 1 to both sides and get 1 equals 10. So no matter what number you add, you're going to get untrue statement.
That
Yeah.
was okay, we did that one.
You go back to number 4 real quick.
Oh. So we got this here?
Yeah.
All right. Oh, let me give you. This is the answer key for that warm-ups. So we haven't talked about number 3 yet, but tomorrow we're going to get into your favorite word problems. So if you're like, come on, Jeff, what are the word problems? It's tomorrow. You hate them. I never heard that. Nobody ever tells me. They're just real life.
It's on that, it's listed, it's listed under 2 right now.
What's up?
I looked at the
Oh, yeah. It makes it look like I did each one individually, which I didn't.